All right, guys, so today we're going to learn some specific terminology that's going to become really important as we move forward in this probability unit. And we're going to talk about something called a union and something called an intersection. You've dealt with these, we just haven't used this terminology yet. So we're going to define those terms and come up with some formulas that'll help us calculate these unions and intersections in the future. So in our first situation, we've got marbles that are labeled 1 through 7 in a bag. And S has been defined as the set of all outcomes when one marble is pulled from the bag. So you're just going to pull a marble, and all the possible outcomes of what could happen when you do that are defined to be S. So obviously that's just going to be 1, 2, 3, 4, 5, 6, or 7. Now we're given A. So let A be the event of pulling an even number. And because we're pulling an even number from the bag, A is a subset of S. So let's define A here just so we can see what these outcomes would be. If it's got to be an even number and it's got to be between 1 and 7, our even numbers would be 2, 4, or 6. So although they didn't ask us to do this, it's good to just see what elements are in set A. And B is the event of pulling a prime number. So in set notation, we can define B, give the elements. All right, what are the prime numbers between 1 and 7? Well, prime numbers are any number whose factors are 1 and itself. Those two numbers have to be distinct numbers, so 1 doesn't count because 1 is itself. 2 is prime, 3 is prime, 4 is not, 5 is prime, and 7 is prime. Okay, so we've defined these two sets, and the reason that's useful to us is because we need to construct a Venn diagram now. So just like we've done in class a couple of times, let's construct a Venn diagram to represent S, and remember that we're going to have circles that represent our subsets, but we have to also account for the fact that there may be elements of S that are not in either of these subsets. So I'm going to call this S, this will be A, this will be B. And why don't you pause the video, go ahead and populate this Venn diagram with the elements that belong in each spot. And hopefully you've done that by now. So I'm just going to pick a number out of the marble bag and put it where it belongs. So let's pick 1. 1 is in set S, so I do have to put a 1 in here somewhere. But is 1 in A? No, because it's not even. Is 1 in B? No, because it's not prime. So 1 has to go out here somewhere. 2 is in S, it's also in A, and it's in B. So 2 needs to go in here. 3 is in S, the greater set, because it's in the bag of marbles. It is not in A, but it is in B. So I'm going to put 3 over here in set B. Still in set B, but not also in A. 4 is only in A. 5 is only in B. 6 is only in A. And 7 is only in B. And so I'm just going to make sure that I've got every number in set S listed once. So these are the elements of set S. 1, 2, 3, 4, 5, 6, 7. I've got all my elements there. Now it's time for some new terminology. So based on this Venn diagram, we're asked to calculate a few things here. And the first thing, this terminology is referring to the union of two sets. So let's define that. So you should pause the video and define this here. But the big key to a union is identifying that that symbol means or. So if you see the upward U, U for union, we're talking about an or situation. What's the probability of selecting an element from set A or from set B? And this is something we talked about on the first day where we introduced probability, and we had a little discussion about what this or meant, who counts. And it's a lot simpler than it seems. You don't want to overthink this. You just want to ask yourself, is this number in either set A or set B? And so let's think about that. Is the number 1 in either set A or B? No, it's not in either one. It's not in A or B. What about the number 2? Well, the number 2 is in set A and it's in set B. So is it in either A or B? Yes, because it's in one or both of them. And that's as simple as it gets, right? This is the section here where it gets a little confusing. Are these numbers in A or B? Because it seems like maybe the fact that they're in both might exclude them. Nope, it doesn't. If you are the number 2 and somebody asks, are you even or are you prime? You would say yes. And in fact, you'd be both. All right, so which of these elements are in A or B? And we could count those up pretty easily now. It's basically all the numbers that aren't the number 1. So of the 7 numbers, so that's the number of possibilities, there are 6 of them that are either in A or are in B. All right, let's talk about this other symbol. And this is called an intersection. The intersection is a much more straightforward concept. This is the probability of selecting an element that is in A and is in B. So the key word here is and. And that's the big difference between unions and intersections. You should think of union meaning or, and intersection meaning and you do want to get those symbols straight. It's easy if you think of the fact that the union symbol is a U. All right, but I'm not going to refer to the intersection symbol as an N because although it does look a little like a lowercase n, the way that it's correctly drawn, it's not an N, it's a different symbol. All right, so let's calculate that. What's the probability of selecting an element that is both in set A and is in set B? Again, we're picking from set S, so the number of possible outcomes here is 7 because there are 7 numbers in the bag of marbles. And how many of the numbers in that bag are both in A, or are even, and are in B, which means they're prime? And I'm going to find those right here in the middle. This number here is both even and it's prime, and that's the only number that meets those requirements, so just 1/7. So the probability of the union in this case is 6/7. That makes sense because when you use the word or, you're kind of broadening the possibilities. If I say, are you tall or are you wearing glasses? That's going to include anyone who's tall and also anyone who's wearing glasses. But if I say and there, now I'm restricting that to just the people who have both of those qualities. So in most cases, you'll find that the intersection is a smaller group than in the union. But this is a question that I want you to answer on your own before we talk about it tomorrow in class. Why isn't the probability of A union B equal to the probability of A plus the probability of B? And before you answer that question, it might make sense to just for yourself calculate the probability of A and calculate the probability of B, which is something we've done before. So this right here is a question that you need to answer. It's going to help inform our discussion tomorrow. So I'm posting the homework section of today's lesson. It'll be a little different than what you've done in the past. It's not on Delta Math or Khan Academy. It's right in Google Classroom. But when you finish these notes, just like always, upload them to Classroom so that I can grade them, and then you can get started on your homework. I'll see you guys tomorrow.